Good morning or good afternoon, depending on when you're watching this, Year 8s. Hope you are ready to rock and roll, get into our next topic, linear equations. This is very much an extension of algebra, just progressing a little bit further into some more graphical ways to represent what we've been learning so far. An introduction to this topic is what we're going to go through today, called inverse operations. Please make sure that you continue to pause the video throughout for when you need to write something down, re-watch it if you need to, make sure you take all the notes with clear working out and headings. Let's get into it. All right, the equal sign. That's probably something that you're all familiar with, but it's also very, very important for this topic. Equal sign. Now I've used some scales here because it's very much a graphical representation of what the equal sign is. It shows the balance between two things. In our case, it shows the balance between two expressions to create one overall equation. When we change one side of the equal sign, like when we have scales, if you add something to one side, you must add it to the other side as well, so that it stays in balance, so that it stays equal. Some basic examples here. In our first one, the expression on one side is 3 plus 4, so the expression on the other side must be equal to this. In this case, it is 7. It could say 5 plus 2 or 6 plus 1. Doesn't matter, as long as the two are equal to each other. In the second example, we have more of an algebraic one. We don't necessarily know what the value of x is, but we must trust that these two expressions are equal to each other because we have an equal sign showing that. All right, so inverse operations. The word inverse, it essentially means opposite. So in the context of maths, adding and subtracting are inverse operations. They're opposite to each other. If I add 3 to something, the opposite to that, or the inverse of that, is to take away 3. Like with multiplying and dividing, works out much the same. They are also inverse operations. If I multiply something by 5, the inverse is to divide by 5. Or in this case here, multiplying by 3 is the opposite or inverse of dividing by 3. Now, quite often we represent inverse operations within a flowchart. Now, a flowchart is just a diagram that essentially shows an expression being created or an answer being created. It's used to represent a series of operations. The first number that we put into our flowchart is called the input number, and then the final number, or the final expression that we get at the end, is called our output number. So let's look at an example. Say we have the number 8. And we want to apply an operation to that. This is how we set up our flowchart. Usually we have numbers or the terms in squares like this, and then we have a series of arrows that show the operations that are occurring. So in this case, plus 5. All right, so we take our initial or input number, we add 5, that gives us 13. That could be your entire flowchart, depending on the question you were being asked, but they can also be a lot longer. For example, if we wanted to add a second operation, multiply by 2. Take our previous answer of 13, multiply it by 2, we get 26. We can keep going if we really want, because we're having so much fun. Subtract 10, and we get 16. We won't go any further, so therefore our input number was 8. We applied a series of operations. Our output number, or our final answer, in this case was 16. So this is how a flowchart is typically set up. Sometimes they don't just have numbers inside them, sometimes they have letters, variables, or entire terms or entire expressions, which is where we get a bit of an overlap with our algebra topic. Now, an important thing to note here is by using inverse or opposite operations, we can reverse the flowchart and work from the output number, in this case 16, and work backwards to get the input number. So for example, if you wanted to start with 16 and go the opposite way, what we would do is we'll draw an arrow going backwards. Now here, what we did was we subtracted 10 from 26 to get 16. So if we want to go backwards, we have to do the inverse of that, which is to add 10. If we want to keep following this pattern, all right, now we're at 26, we want to get to 13. What we did was we multiplied by 2, so the inverse of that is divide by 2. And finally, 13 to get to 8, Initially we added 5, so we'll apply the inverse operation. We will subtract 5. So depending on the question or the scenario, sometimes you need to work backwards by using inverse operations to solve for the input number. Alright, we're going to go through 2 examples. So example 1. Find the output expression for this flowchart. Now it might seem pretty straightforward at first. We're applying some basic operations, multiply by 3, add 2, divide by 4. But in this case, we're starting with a variable or a pronumeral instead of a number. So we're going to get a whole expression at the end, not just a singular number. So our first operation is to multiply by 3. So in that next box, we could write x times 3. But because we know from algebra, we typically don't write it like that. When we're multiplying a letter by a number, we would typically write it like this, where our coefficient is 3, and then we have a variable x, so 3x. Our next operation is we are plussing or adding 2. So we're going to write this out as a whole term, 3x plus 2. So we don't necessarily need to have just a single number inside our flowchart. It can be whole terms or whole expressions like this. Finally, we're dividing by 4. Now this is a common mistake that students and people make when it comes to dividing. We need to divide the entire expression by 4, not just the 3x or not just the 2. The whole thing needs to get divided by 4. So if I do 3x plus 2 divided by 4, it'll come out looking like this. So that's our best, most efficient way to write our output expression. And then just a little conclusion, the output expression is 3x plus 2 divided by 4. And that's our answer. In example 2, starting with x, draw the flowchart whose output number is given by the expression -2 in brackets x plus 6. So a little bit of a different scenario. In this case, we've still got our input number, which is x, but now we need to create a flowchart which gives us the eventual output number or output expression of -2 brackets x plus 6. Alright, so let's set up our flowchart. We know that the starting term is x, but we've got a couple of operations in here. We've clearly got the plus 6. We've got a -2, which we know is multiplying to the x plus 6 because it's outside the bracket. So we need to think about, all right, which one of these are we going to apply first? This is where our knowledge of BIDMAS can come in handy. Because we have x plus 6 inside the brackets, we always do whatever's inside a bracket first when we do BIDMAS. Works much the same when we're drawing a flowchart. Because we have plus 6 inside the bracket and then the -2 being multiplied outside the bracket, we're going to do the plus 6 first. So let's set that up. X plus 6, when we write that out, it'll look like this. Now we simply, because that -2 is outside the bracket and x plus 6 is inside, the whole thing gets multiplied by -2. So that's going to be our next operation that we apply. Multiplied by -2. With that, we'll get our final output expression in our flowchart, -2, x plus 6 in bracket. If I wanted to go back the other way using inverse, well, we'll just divide by -2 first, and then I would subtract 6 to go back from the final expression to get back to x. Now that you've got these awesome knowledge and skills and these amazing, beautiful notes inside your books, have a go at the questions listed on the slide. Make sure you check back with your teacher if you need help with anything throughout this topic. Thanks, guys.